Welcome back, folks. Today we're going to get going with Chapter 12, and Chapter 12 is all about circles. Now, we've already done a little bit with circles this year as far as finding circumference, finding area. In Chapter 12, we're going to dive much deeper into it. With 12.1, we're going to start by talking about circles and arcs. Objective to find the measures of arcs, arc length, and area of sectors. We'll explain what all that means as we go here. All right, two vocab words we're going to start off with, and really everything we do today is going to be based on these two terms. First idea is the idea of a central angle. That's just an angle whose vertex is the center of a circle. So for example, shaded in red here, we have this central angle because we'll say the red dot here is the center of my circle. And the other piece we're going to kind of combine with that as we go is the idea of arcs. I'm going to say arcs are sections of the circle's circumference. Okay, so we know that the circumference of a circle is the distance around the circle, the perimeter of the circle, in other words. An arc is going to be a single chunk of that. Okay, three types of arcs we're going to deal with. First one is semicircles. Those are just half a circle. So for example, in blue, I am shading a semicircle, if I can trace it here. Okay, it's running from one end of a diameter to the other. I know this is a diameter because it goes through the middle of the circle. So that's how we know it's a semicircle. Okay, we have minor arcs, which are arcs that are smaller than a semicircle. So for example, on the right side here in red, we have a minor arc that is less than half the circle. Okay, then last one are major arcs. Those are larger than a semicircle. So if I start here and start just going around to the halfway point, we'll say, and then keep going, that'd be an example of a major arc. So let's begin today by identifying and naming arcs. Problem 1 says, what are the minor arcs of circle C? Well, like we said, a minor arc is anything less than a semicircle. For example, what you see in blue would be a minor arc. Now I'm going to name that arc with the two endpoints A and B. I'll just say AB with an arch over top of that. We'll say that's our arc symbol. Okay, now just like with naming segments, just like with naming angles, I can do it in different orders. So for example, this one I could also say BA with my arc symbol over it. Whether I'm starting at A and ending at B or starting at B and ending at A, we're still talking about the same part of that circle. Okay, so two different ways to name that arc. Okay, what else do we have? We have BE would be a minor arc. We also have DE. And then the last one here, let's see if this color shows up. Maybe you can see that. We're doing yellow. AD would be my last minor arc. Okay, so reminder, minor arcs, less than the semicircle, less than half the circle, and you'll just name those with 2 points. All right, part B asks us to name all the semicircles. Now a semicircle we said was half of a circle. So for example, if I shade the bottom of the half of this circle with blue, that'd be an example of a semicircle. Now when I name a semicircle, I actually need 3 points. I'm going to call this one ADE with the arc symbol above it. So I need the 2 endpoints, and then with a semicircle, I also need another point in between. The reason for that is if I just called this arc AE, how would you know if you're talking about what I have in blue here or what I have in red? Both start at A and at E, okay, but it's that point in the middle that gives it direction. So on top, I'd say that's arc ABE. All right, I'm seeing 2 more semicircles. We could say BED. And then the last one I'm seeing is BAD. Okay, and it's okay if they overlap when we're naming them here. There's my 4 semicircles for this problem. Okay, last part, C, name all the major arcs. Okay, so with a major arc, we are talking about an arc that's more than a semicircle, so more than a half a circle. So let's say I start at A and start going around through B, through E, so a semicircle, then you keep going all the way to D here. Okay, just like with a semicircle, I need 3 points. We'll say the endpoint A, we'll say the endpoint D, and then since this one goes through 2 different points in the middle, I can pick either one of them. We'll go with B. Okay, but besides flipping the order, I could have also used the E in the middle. I could have said A, E, D. Okay, whether I start at A and run through B or E and end at D, I get the same thing either way. Okay, so those would be 2 ways to name the same arc. All right, other major arcs I'm seeing. Okay, basically start, run halfway around the circle, and then just keep going to the next point. So we could say that B, E, A is another arc on this circle. Got a few more. We could go A, B, D. Whoops, wait a minute. We already did that one. This gets a little tricky just with things overlapping. Let's try that again. We could go DAB. Sorry, DAE we'll go with. And then there's one more. This gets a little tricky as I try to keep track of what's overlapping. I think EDB would be the last one. That'd be the last one I haven't named here. Okay, a little tricky naming them all in this case just because of all the overlapping. A little bit easier, we just have to identify one. That's what we stick with for these problems for the most part. So we're able to break our circles down into arcs, sections of the circle's circumference. Now the next thing we're going to do is look at a way to give a value to our arcs. Okay, to talk about how big or small they are, or basically how much of the circle they take up. That's going to be with the idea of arc measure. And the way we'll define that is we'll say that the measure of a minor arc is equal to the measure of its corresponding central angle. So for example, we'll say the measure of arc RT, what we see in red here, is just equal to 50 degrees because the central angle that forms that arc, angle RST, is just 50. Okay, so when we're talking about a central angle or the measure of the arc, we're really talking about the same thing. Okay, the arc measure just gives us kind of a different way to think about how it relates to the circle. All right, so that's it for minor arcs. For major arcs then, we'll say the measure of a major arc is the measure of the related minor arc subtracted from 360. Okay, so in this course, we actually haven't talked about angles that are bigger than 180. We haven't given those a name or anything like that yet. So we'll do for major arcs such as TQR, which you see in blue here, is we'll just say it's equal to 360 minus that minor arc. Okay, 360 for the full circle minus the part we're not talking about. So 360 minus 50 will give us 310, okay, for that major arc. Next thing we're going to talk about is how we can combine and subtract arcs, okay, using the arc addition postulate. First, though, let's talk about adjacent arcs. Okay, those are just arcs on the same circle that have exactly one point in common. So for example, here I'd say that arc AB and BC are adjacent to each other because they share this point B here. Remember, when we say adjacent to, we mean next to. And then that idea is going to allow us to add and subtract arcs from each other, okay, leading us to the arc addition postulate. It just says the measure of the arc formed by 2 adjacent arcs is the same as the measure of the 2 arcs. So for example, the measure of major arc ABC, the whole thing you see in red here, will be equal to the measure of AB plus the measure of BC. Okay, again, we're talking about the measure of arcs. All we're talking about is the measure of central angles. So really, since we're able to add and subtract angles to each other, we can do the same thing with arcs. Okay, so let's look at calculating some arc measures. Problem 2 just says, what's the measure of each arc in circle O? Part A, we want to know arc TU. Let's find that first. That is a minor arc, TU, right there. And for that, we're just going to use the definition of arc measure. We said it's equal to the measure of the central angle that makes that arc up. So if I trace that arc back to my center, I have a central angle of 60 degrees. That's why that arc measure is just 60 degrees. Okay, B, we want to know the measure of arc SU. Now SU here is made up of two adjacent arcs, ST and TU. I know ST is 20, TU is 60 again. So for SU, we'll just take 20 plus 60, which gives us an 80 degrees for a total for that arc SU. Okay, next up we're talking about arc RST. So what do we have here? If we start at R, run through S, and stop at T, we're looking at a semicircle, half the circle. Okay, again, I know that because it's going from one end of a diameter to the other. Now we know the measure of a straight line or straight angle here is 180. Okay, that means the measure of that arc then would just be 180 degrees as well. Okay, and that'll hold true for any semicircle you look at. No calculations necessary. You can just say 180. All right, last one, minor arc RS. Okay, RS is less than the semicircle, less than the arc in green. And how much less is it? It's 20 less. Okay, we're 20 short of that 180. So just like we can add angles together, we can also do subtraction to find them. So for RS, we'll take 180 for the semicircle minus 20, which gives us a 160 degrees, right, for that arc measure of RS. Okay, went through that kind of quick, but really we're doing the same thing we've been doing with angles all year long. Okay, just looking at them from a different perspective, okay, from the perspective of arcs on a circle. All right, next concept we're going to talk about is the idea of arc length. I'm going to say arc length is a fraction of the circle's circumference. Okay, so if I want to know the length of arc AB, that's going to be the distance from A to B along the side of my circle. So that's a length again. Arc measure is a degree measure, it's an angle, whereas arc length is going to be a length. Okay, the way we'll calculate that, we said it's a fraction of a circle, so what we'll do is we'll take the measure of the arc we're dealing with, divided by 360, that's going to tell us how much of the circle we're dealing with, and then just multiply that by 2 pi r, 2 times pi times radius, the circumference of the circle. So here we have the fraction of the circumference. Okay, or I could use pi times d for the circumference. So again, measure the arc divided by 360, that's how much of the circle we're dealing with, times pi times d, again, times the circumference. All right, so in problem 3, let's look at finding arc length. 3 says, what's the length of each arc? Part A, we're looking at arc CD, which is that chunk of the circle. Okay, the formula we just gave you said that that was equal to the measure of arc CD divided by 360. Okay, times the circumference. For circumference, remember, we can use 2 pi r or pi times d. Here it looks like this 9 is the diameter, so we'll just say pi times d. All right, filling in the numbers, our arc measure for CD is going to be 90 degrees, because that central angle is a right angle. So we'll say 90 over 360 times pi times the diameter, 9. And again, what this formula is doing is if I look at this fraction here, 90 over 360, if I reduce that, that's going to reduce down to a fourth. So here we have a fourth of the total circumference. If I multiply that out, I'm going to end up with a 2.25 pi centimeters. If I leave my answer in terms of pi, it's just going to 90 divided by 360 times 9. Okay, or depending on what the problem's asking for, I could multiply that by pi, multiply the pi through, and I'd end up with a 7.1 centimeters. Okay, Part B is a similar question, actually kind of two parts in Part B. Why don't you take a minute, pause the video, work Part B out, and then hit play to check your answers. All right, last thing we're going to talk about is finding a fraction of the circle's area as opposed to circumference. Now we're going to call a slice of the circle's area a sector. I'm going to say a sector is a region bounded by an arc of a circle and the two radii to the arc's endpoints. So if I create an arc AB, and connect the endpoints of the arc to the center with radii, okay, the area in between, that's my sector. Okay, we're going to find the area of a sector in a similar way that we found the length of an arc. We'll take the measure of the arc divided by 360, so a fraction of the circle again, and then times pi r squared, the area of a circle formula. So here we just have a fraction of the circle's area. All right, so problem 4, part A, find the area of each stated sector. In A, we'll go 36 for the arc measure, divided by 360. Okay, that's my fraction of the circle. If I reduce that down, I'd get a tenth. So we're talking about a tenth of the circle's area. Okay, times the area formula, which is pi times radius squared. So in terms of pi, I can go 36 divided by 360 times 6 squared. That gives me a 3.6. So I can say 3.6 pi centimeters squared. Okay, squared units because we're talking about an area. Okay, that's finding not arc length, sorry. That's finding the area of a sector. Okay, B is the same idea. Once again, take a minute, pause the video, work through that one, and then press play to check your answer. All right, so that's it for lesson 12.1. Go ahead, get your practice in, get the homework done, ask questions if you got them. We'll be here to help you out if you need it.